Welcome. In this video, I will be sharing with you some expert tips to get better at programming and to polish your software engineering skills. A disclaimer before I start with this video, all the tips that I mention are not necessarily for quote unquote experts, but it would be a little more valuable to implement them before you even reach a certain level because it is a little difficult to understand how you should be designing a database when you don't even know how to write a single SQL command or just know how to print hello world in a different language. Or you could start implementing them side by side as an intermediate programmer to advance to a completely different progression level. With that being said, let's get started. Number 0, get to know more about the theory behind computing. When I talk about theory, I mean the logic behind the actual computing, which means database management, computer networking, operating systems, embedded systems, and all the things that just go into functioning your computer the way it does. If you know what there is, then more than what meets the eye, it puts a lot of things into perspective. If you're a full stack developer, think about how the code is working on the backend when you place an order on Amazon, how the information is stored so reliably, and how you're able to track your parcels so accurately, or what happens when you search on Google, how the search engine is scrolling through hundreds and thousands of web pages to give you the most accurate result in under a second. Here, just don't scratch the surface. Go deeper and learn about performance, caching, and testing. Learn about the HTTP protocol and learn how the web really works because at its core, you are not just a front end engineer or a back end engineer, you are a web engineer. Number 1, learn about system design. After a point, you start to think about scalability issues. When working in bigger organizations or even in startups, you have a priority. Do you want to introduce the latest feature in the quickest way, or do you want to do it in an effective way so that future developers have an easier time building upon it? Sometimes it's a combination of both, but knowing how to design scalable and effective systems is vital to becoming an irreplaceable software engineer. You should really learn about concepts like load balancing, consistent hashing, microservice architecture, and so on. Number 2, learn about the math behind coding. This especially helps a lot when implementing certain advanced data structures and solving problems, and also a little bit in machine learning, artificial intelligence, and neural networks. If you're someone who studied CS in college, you're going to be familiar with topics like linear algebra, statistics, formal automata theory, discrete mathematics. Understand their applications in real world and how they're implemented and used. If you didn't go through this in college, there are a lot of free courses available on MIT OpenCourseWare and Free Code Camp. I have taken some of them and I think they were personally really good and helpful. Number 3, deploying application. It is kind of useless to write code that nobody is gonna ever see because coding is just a tool to solve problems. You're coding to fix a problem or to introduce a feature that is going to make the user's life a lot easier. To widen your perspective as a developer, you really need to know how the code gets built, packaged, shipped, and deployed. It is time for you to understand the full software life cycle, what continuous integration and delivery really mean, and how you can deploy your own applications with best practices. At the same time, cloud certifications go into too much detail about applications and services that you may not necessarily need as a developer. Knowing at which network level an application load balancer works is really interesting but not necessary. Get a good understanding of cloud, version control, and integration tools instead. If you understand how to deploy applications in real life, you will be able to help your team from the production phase to until when a feature gets tested and deployed to the real world. Number 4, collaborate with other developers. Have your code reviewed and review other developers' codes. Take feedback, understand the different aspects that go into writing the code and what even goes behind the scenes before code is written. What all logic goes behind their heads? How is the system design process like? And what all processes come and go in their heads before they even start writing a single line of code. Number 5, contribute to open source. Open source means software code that is designed to be accessible to the public. Anyone can see, modify, and distribute the code as they see fit. There are a lot of organizations that are committed to open source and want to introduce to new people in the field how to contribute towards it. They also participate in a lot of events to help encourage people to go into open source and spread awareness. One of the most notable among them is Google Summer of Code. You'll understand how to contribute to projects by learning about open source. Number 6, unit testing. How do you know if your software is working or not? You have to test it, right? But how do you test it? Testing it after each and every line of code is very tedious. This is where unit testing comes into picture. Unit testing is defined as the kind of individual testing about different parts of code individually. Unit testing of the software is carried out during the process of developing the application. An individual component may either be an individual function or a procedure. Software testing techniques by means of which individual units of a software are tested include group of computer program modules, usage procedures, and operating procedures are tested to determine whether they are suitable for use or not. It is a testing method using which every individual module of code is tested to see if there was any error made by the developer themselves. It is correlated with the functional correctness of all the modules. Number 7, teach others. This can be in the form of taking coaching classes, both offline or online, maybe on a platform, paid, unpaid, anything. If you teach others, you're often going to be breaking very high level concepts into simple chunks for an unexperienced student. When you do this, you're also drilling the knowledge into your own head, and that really adds up. Teaching various concepts to various age group of people will really help you to know how to teach a 10-year-old about software engineering and how to teach someone who's in university. You will be able to know how much to divulge and what information to give them based on their age. If they're very young, you can just simplify it and dumb it down for them. And for someone who's an adult, you can just really go into the inner complexities of the concept and solidify everything in their head. Number 8, take up a job. Having a full-time job is going to thrust you into an environment where you use your coding skills all the time, interact with senior developers, help junior developers with their code, and design applications with a team and work on projects together. Your growth with respect to your technical skills is going to be exponential because now all you think about is coding and you practice it every day, which is a proven method to improve in some. This is also a great way to advance in your career as a newbie. Not only will you be coding full time, but you will also be under the guidance of senior developers, which will set you on the path to be one yourself. Number 9, freelance or become a contractor. By becoming a freelancer, you often have to design entire websites and apps by yourself from scratch. That requires a lot of knowledge and an expansive skill set. That will get you to the status of a nearly complete developer because let's be honest, there is no such thing as a complete developer. You can just go on and on learning, and there are still going to be some things that you haven't explored. This also puts into perspective how workflows should be designed for efficiency. It will also help you acquire business skills which are truly important in today's economy. Who knows? You might even end up coding your own startup from scratch. These were all the tips for today. Even I am implementing some of them because I'm an intermediate at best. I don't know a lot about coding too. Did you find these helpful? Let me know in the comments. As always, like, share, subscribe, and hopefully I'll see you in the next one. Bye.